In this question, a scientist wants to determine what volume of hydrogen gas, H2, at STP, that's standard temperature and pressure, would be needed to react completely with 202 grams of sulfur, S8. Let's start again by balancing our equation. So I'm going to draw a little table with my elements I have in my question, which are hydrogen and sulfur. So in the unbalanced equation, I have 2 hydrogens in H2 in my reactants. I have 8 sulfur in my S8 in my reactants. And in my products, I have H2S, so 2 hydrogen and 1 sulfur. So hydrogen appears to be balanced to start with, but sulfur isn't balanced. So I'm going to add an 8 in front of my product side on the H2S, and I'm going to recount to see if my equation is balanced now. So now I have, again, 2 hydrogens in my reactants, 8 sulfur in my reactants, and in my products I have 8 sets of H2S. So 8 sets of H2 is 16 H in my products, and 8 sets of S is 8S in my products. So sulfur now appears balanced, but hydrogen isn't anymore. So I'm going to go ahead, I'm going to add an 8 in front of the H2. So I have 8 sets of 2, which will give me 16, and I think that'll balance it. Great, so our equation's balanced. We can fill those numbers in. And again, remember, usually we don't include the 1 if we're just writing out an equation, but on this platform, you do need to enter 1. Okay, so we balanced our equation. Now let's have a look at our question. So we're trying to figure out the volume of hydrogen needed, and we're starting out with 202 grams of S8 sulfur. So we're starting with grams of S8. We're trying to get to liters of hydrogen gas. So first we've got grams of S8. We're going to need to get them to moles of S8 because remember our equation gives us the mole conversion between any two things. So we're going to first need to convert grams to moles of S8. Then we're going to need to convert moles of S8 to moles of H2. And then finally, we're going to need to convert moles of H2 into liters of H2 gas. So we've got 3 conversion steps in there. We're going to start with converting from grams of S8 to moles of S8. So we're going to need to know our molar mass. So let's head to the periodic table and find the molar mass of S8. Let's first find sulfur. Here it is in our periodic table. So sulfur has a molar mass of 32.07 grams per mole. So for S8, that has 8 sulfurs in it. So it's going to be 8 times 32.07, which is going to get us 256.56 grams per mole. So there's my molar mass for S8 sulfur. So we had 256.56 grams of S8 in 1 mole of S8. That's what grams per mole means. So there's our first conversion factor we're going to be using for our first step in our dimensional analysis table. So let's do that now. So we've got grams of S8 on the bottom because that's going to cancel out. We're converting into moles of S8. And for our conversion factor, we know 1 mole of S8 is equal to 256.56 grams of S8. So there's our first step. Our next step is going to be converting from moles of S8 to moles of H2. So let's go ahead and fill in our units in our dimensional analysis table. Moles of S8 are on the bottom because we want that to cancel out. And we want to end up with moles of H2. Now we can have a look in our equation. Here's H2 and here's S8. We need 8 moles of H2 for every 1 mole of S8. So in here, we're going to have an 8 with our moles of H2 and a 1 with our moles of S8, because from our equation, we had 8 moles of H2 is needed to combine with 1 mole of S8. That's our conversion factor from our equation. Let's check that. So for our last step, we're converting from moles of H2 into liters of H2. And remember, we're at STP, which is standard temperature and pressure. And at STP, 1 mole of gas is equal to 22.4 liters of gas. So there's our conversion factor going from moles into liters. So we can fill that in our dimensional analysis table. We're going to have moles of H2 on the bottom because we want that to cancel out. And we're ending up with liters of H2 on the top. And using our conversion factor, for 1 mole of H2, we have 22.4 liters of H2. Okay, great. So there's our dimensional analysis table ready. Now we can go ahead and multiply everything on the top, multiply everything on the bottom, and divide top by bottom. Then we can cancel units that are the same on the top and the bottom. So grams of S8 cancel, moles of S8 cancel, moles of H2 cancel. We're just left with liters of H2, which is what we're trying to find. So that's great. We can go ahead and do our calculation. So we've got 202 multiplied by 1 multiplied by 8 multiplied by 22.4 liters of H2. And we're dividing that by 257 multiplied by 1 multiplied by 1. So if we put that into our calculator, we're going to get out 141 liters of H2. So let's check that in our answer box now. Awesome. So again, this works exactly the same as any other stoichiometry problem that we've done. The only difference is we're also using this moles to liters conversion factor, where 1 mole is equal to 22.4 liters of gas at STP. Other than that, we need to remember that our first step is getting everything into moles. So first we're going to convert from whatever we start with into moles. Then we're going to convert between moles of one thing in our equation to moles of another thing. And then finally, if needed, we'll convert from moles into liters or grams or whatever it may be for our last step.